Okay, class, this video is specifically for my B1 class because they will time runs short and I won't see them for the rest of the week, but certainly might be helpful for the B6 class as well. What I'm going to go over is how to use R to assess correlation and linear models. Apologies, I just noticed this was in the background. This is my daughter's daughter. So I'm gonna put her back. Anyway, so let's hop on R. I'm gonna share the screen right now. Show the whole desktop. There I am. Here we go. So what I did here, and this is in the discussions section of Canvas. I put all these numbers. This is the exact example from the book. Okay, so here I have, let's clear my objects. I'm going to make a new object called miles, which is going to be equal to the list of these values, and price, which is the list of these values. Okay, now if I want summary information from them, I can put that here. You'll notice the first time I'm putting a semicolon here, and that will run 2 lines of code. So here it's going to show in the first line the summary of miles, secondly the summary of price, and for whatever it's worth, also the standard deviations of these. Okay, so again, I just made 2 different objects, and those objects are just going to be data variables. Now, to plot on a scatter plot, I have here this line of code with 3 arguments. The first is X, Y, and main. I could even type in, and I know I haven't done this in class yet, but it might be helpful to see, here's plot, here are a number of arguments. If I run this, you'll see, I can't actually see my own screen, the scatter plot here. I'll zoom in. Oops, it's about to be drawn. Okay, here we are. This scatter plot of data values, which looks exactly like the one from the book. So here we have the scatter plot. Now, of course, the next thing we learned was correlation. And here you can see is a very easy line of code to determine correlation. It's core, X, and Y. Okay, let's run that. You see here, whoops, sorry about that. You see here, we have a negative correlation of 0.82, which is a pretty strong correlation. Okay, and you can see, if you look at the data points, you can see clearly there's a negative association. And if you drew a line, you might see it's would include a lot of variables kind of close together. So we have the correlation. The next thing we do, because there is a correlation, it's really not 0. We want to make a linear regression. Okay, and look at the code we have here. We made a new object called LR model, obviously linear regression model. It's equal to the argument LM price tilde, that's the button, you press shift and the button above, tab, miles. So here you have your response variable and your explanatory variable. And if you run that, you're telling R, make a linear model with price as the response variable and miles as the explanatory variable. Now, all you have to do, it's pretty easy to do this kind of model, is then run summary of the model. Remember, before we looked at the summary of a specific data set, here we could get the summary of what the model would be. Let's go back over there, okay? Here you see a couple of important things. The residual standard error, right? So we talked about that in class. Here's the multiple R squared and the adjusted R squared. Here's the intercept. You might have remembered it was 38,260. And here is the slope of the line next to miles. And you remember that it is negative 0.1629. Okay. So now we've made the model. We understand the intercept. One thing I want to do is add the regression line to the scatter plot. And all I have to do, the first thing that there has to be is there has to be a plot. So You run the plot, you have the scatter plot down. I'll actually go ahead and copy this. And you know what I'll do to make it a little easier is I'll write scatter plot of mileage and price for F-150 with regression line. And you know, and I showed this in the last video, but if you use this n back for one of the slashes n, oh, that's the wrong one. There we go. You get 2 lines. It looks like I could even afford to do this over here. Okay, so now I made the plot with its own title. Here again, the arguments are x, y, and main. And now I'll run add line. And you see that the regression line, and all I had to do was put add line, and then I just had to put that model object, color equals, and obviously it could be whatever you want. If you want to change the thickness, it would be line width is equal to, let's say 3. There you go, a little bit thicker of a line. Okay, so now that was pretty easy. We found the correlation. We made a scatter plot. We found the correlation. We also made a linear model. We looked at the linear model. One thing we didn't do, we got the R-squared values. And we got some information about the residuals, but we didn't look at the residual plot. So it's actually super easy to do this. All you do in this one is you say plot and then the LR model. Okay. And if we plot that, we see the residuals and fitted line. And you can see here, they're normally distributed. Okay. Now there are a couple other diagnostic plots here, but let's just go back to residual versus fitted. This is, I think, all we talked about in chapter 3. So there's your residuals versus the fitted values, and you see that there's no pattern. So that is the R that you should have down. Let me add, because I might not give the code for this next one, you should have it all written down. I'm sorry, there's one more thing I want to do, and that's briefly show you, for instance, how to find world happiness. Sorry, I have to jump around a little bit. I'm going to give you guys an assignment based on the world happiness data set. Here, we introduce the website just as we normally would. Introduce the data set. You can see it's a web link to a CSV file. And if I want to first, and I'll just show you this part because I want you to run a correlation. You'll notice here a correlation, a regression, and a scatter plot. You notice here I made these data values miles and price to plot them. If you're doing something like correlation or a scatter plot or a regression, all you have to do is plot happiness data, score, happiness data, cash money. Let's look at perceptions of corruption. Okay, not that linear of a relationship, for instance, but so let's get a better one. GDP per capita. Okay, much more linear relationship. Okay, now I'll show the hint here because if you're still watching this, you deserve at least one extra hint. If you're making a linear model, and you know what, actually, what I'm going to do is LM of score and GDP. You do LM. You can, this is, of course, the response variable. And this is the explanatory variable. If you run that right there, or rather, as I showed you. Okay, so there are my hints. You should still interpret things more than just plotting the numbers in the homework assignment. But I hope this was a useful introduction to the code. You see, it's much less code than when we were kind of visualizing things, which is sort of the beauty of R. It's really easy to pop out a correlation or make a linear model. Okay, I'm gonna stop sharing now.